The definition eccentricity of an ellipse. What is eccentricity of an ellipse? Let us see the definition here. The eccentricity of an ellipse is the ratio. What is the ratio here? It is the ratio of the distance from the center of an ellipse to one of the foci and to one of the vertices of the ellipse. Here, eccentricity is always denoted by small e. To understand this definition, look at the figure here. So here O to F, F1 to O or O to F2 is the distance from center to the any one of the foci is C, and one of the vertices of ellipse. So from center to A, O to A or O to B are the distance from center to any one of the vertices. It is denoted by A. So it is the ratio of C and A. This is eccentricity formula. From that we have C equals to A. Now we derive standard equation of an ellipse. So standard equation of an ellipse is the simplest if the center of the ellipse is at origin and the foci are on the x-axis or y-axis. Here the origin at the center at origin and foci are on x-axis or y-axis. If the foci are on x-axis or y-axis, how the ellipse figure here? Let us check the ellipse figure here if the foci are lies on x-axis. Suppose this is the ellipse, here F1 and F2 are the two foci. Here O is the midpoint of the this x-axis and a line passing through O perpendicular to AB is CD. This is x-axis and this is y-axis. Here the foci are lies on x-axis. That's why here the foci F1 and F2 completely lies on x-axis. We know the coordinates of F1 and F2 here, C comma 0 minus C comma 0. So this figure represents foci on x-axis. If the foci on y-axis, the ellipse figure like this. The ellipse figure like this. Here, in this case, this is F1 and this is F2. A line passing through F1 and F2 is y-axis. This is vertical line. And this is the midpoint of this line which is passing through O perpendicular to y-axis is x-axis. So these are the coordinates. This figure represents is an ellipse whose foci on y-axis. This is the, in this case, here the x-axis is major axis, but foci on y-axis case, ellipse, major axis is y-axis. In this case, minor axis is y-axis, but in case of foci on y-axis, minor axis is x-axis. Okay. This is the rough idea if the foci of an ellipse lies on x-axis or y-axis. Let us derive the definition of an ellipse with the foci on x-axis. With the foci on x-axis. We know the ellipse figure if the foci on x-axis like this. Here AB is the A comma B are the vertices and O is the center whose at origin. and passing through O, that origin is vertical line, that is y-axis. So this is C and this is D with coordinates 0 comma B and 0 comma minus B. Here F1 is the focus which has the coordinates minus C comma 0, and F2 is also focus, has the coordinates C comma 0. Suppose we choose a point P x comma y on the ellipse. Now we join P to F1 and P to F2. Here let us choose, to derive the equation of an ellipse here, let us choose P of x comma y be any point on the ellipse. Now we are using the definition of ellipse. Now by the definition of ellipse here, the distance from P1 to P to F1 plus the distance from P to F2 is a constant. So that's why Pf1 plus Pf2 equals to a constant. We assume that constant as 2a. So Pf1 is the distance from P to F1. Pf2 means is the distance from P to F2. We use the distance formula. The distance formula is x1 square root x2 minus x1 whole square plus y2 minus y1 whole square, or this is the distance formula between any 2 points AB. We use the same formula here for Pf1. Here P coordinates, F1 coordinates and F2 coordinates here. So x plus C whole square plus y minus 0 whole square plus Pf2. We use Pf2, same formula. Here x minus C whole square plus y minus 0 whole square. Here x plus C whole square plus y minus 0 whole square means y square plus x minus C whole square plus y square is equals to, so right here is equal to some constant, that is 2a. Now the second term taken it to right hand side, the remaining part is square root x plus C whole square plus y square. Now the second term of the above step taken it to this side, then we have 2a minus square root x minus C whole square plus y square. Now taking squaring on both sides. So square root x plus C whole square plus y square is equals to 2a minus square root x minus C whole square plus y square whole square. Here root square cancel, the remaining value is x plus C whole square plus y square equals to, here to simplify we use a minus b whole square formula. A square means 4a square minus 2ab means 2 into 2a into square root x minus a whole square plus y square plus b square means square root x minus a whole square plus y square whole square. Square root square cancel by using the formula a minus b whole square. Now x plus c whole square plus y square equals to 4a square plus 2 into 2a means 4a, and remaining part is same. Now on both sides y square is cancelled, the remaining part is x square plus c square minus 2xc equals to 4a square minus 4a square root x minus c whole square plus y square, and the remaining part is same by using the formula a plus b whole square or a minus b whole square. Here x square c square cancel on both sides. Then we have the all a terms taken it to one side and the remaining term taken it to the left side of the equation. Now taken 4 on both sides, 4 cancel. Then the remaining part is a square root of x minus a whole square plus y square equals to a square minus xc. Now square root x minus a whole square plus y square equals to a is taken to right hand side. Now a square minus xc by a. Now the denominator can be split to the numerator like this. Here a square a, 1a cancel. The remaining part is a minus xc by a of the right hand side of the equation. Now squaring on both sides to eliminate the root here. X minus a whole square plus y square, root square cancelled here. A minus c by a x whole square. Now here a minus b whole square formula applies. Here x minus a whole square means a minus b whole square formula, and right hand side also a minus b whole square formula. A square plus b means c by x, that is c square a square x square b square, minus 2 into a means a, b means c by ax, 2ab. Since a minus b whole square formula. Here a cancel and minus 2ca, here the remaining part is minus 2ca cancel. Then the remaining terms are x square plus c square plus y square is equals to a square plus c square a by a square into x square. Now x terms taken it to left hand side of the equation. Then x square minus c square by a square into x square plus y square equals to a square minus c square. Now x square is common from first two terms. Then we have 1 minus c square by a square plus y square equals to a square c square means we have the relation in above. Since a square equals to b square plus c square, from that b square equals to a square minus c square. So in place of a square minus c square, we put the value b square. So x square of, take LCM here, a square minus c square by a square plus y square equals to b square. So x square of a square minus c square means b square by a square plus y square equal to b square. Now dividing b square on both sides of this equation. So here to the first term, on dividing b square cancel, then the remaining value is x square by a square plus y square by b square is equal to b square by b square means 1. This is the equation of ellipse whose foci lies on x-axis. Similarly, all of you try remember, in this case x-axis is the major axis. In this formula, the denominator of x square is greater than the denominator of y square. So all of you try equation of the ellipse whose foci lies on y-axis. Remember, the ellipse figure whose foci lies on y-axis is like this. In this case, the ellipse equation is x square by b square plus y square by a square is equal to 1 if b greater than a.